Hey everyone, we're starting geometric sequences this week. It's a continuation a little bit from last week with our word problems of growth and decay. It's still exponential. The equations are exponential, but these are sequences, so they're a list of numbers. A geometric sequence is a sequence of numbers where the next number is found by multiplying the previous number by the same ratio. If you remember, we did arithmetic sequence way back the first semester. We said the common difference. A geometric sequence has a common ratio. It means it's being multiplied by the same thing over and over and over again. For instance, 4 times 3 is 12, times 3 is 36, times 3 is 108. So this is a geometric sequence. It can even be multiplied by negatives. 2 times negative 2 is a negative 4. Negative 4 times negative 2 is positive 8. Times negative 2 is negative 16. Times negative 2 goes back to positive 32. So that's a geometric sequence. If you remember when we did these, also we never say it's being divided by the same number. We always say it's being multiplied by the same number. So if it's going down, then you say it's being multiplied by a fraction. So 81, I know that 81 divided by 3 is 27, divided by 3 is 9, divided by 3 is 3, but we would say it's being multiplied by 1/3. All right. So whatever it's being multiplied, you just flip the fraction and say, I'm sorry, whatever it's being divided by, you just flip the fraction and say it's being multiplied by that fraction. So if it's being divided by 7 every time, then you would say it's being multiplied by 1/7. All right. So when we go to the next screen, here's some types of, here's the two formulas. The two formulas are explicit formula and recursive formula. And if you remember, this, when you see a little subscript here, this means A1, this means the first term. All right. If it said A to the 30th, that would be the 30th term. All right. R stands for the common ratio. All right. So whatever the first term is, sorry, Google does not have a good multiplication button, so I had to use the star. That means multiplication. So A1 times the common ratio raised to the n minus 1. Now this is what distinguishes sequences is the n minus 1. When we're doing a sequence of numbers, we always subtract 1 from the term number so that we could and it fits perfectly because we're starting off at term 1 instead of term 0. All right, so we have to subtract it. So this is the explicit formula. If you remember, this is the one we always use in all of our problems when we're doing any type of calculations. We always use the explicit formula. The recursive formula is only there to tell us what the common ratio is and to tell us what A1 is. That's all the recursive is good for. Remember, that's the one that just gives us the next number. So if I don't know the previous number, I can't find the next number, and so it's pretty much obsolete other than just giving us the common ratio and A1. All right, so let's look at some of the other things that we're going to be doing. There's some types of problems we're going to be doing. Identify whether it's a geometric sequence. Is it being multiplied by the same thing? Take a geometric sequence and put it into both formulas. All right, so taking the numbers out of the sequence and put it in a formula. Given a formula, make the sequence. All right, give the first 5 terms or the first 3 terms, or given the formula. Use geometric formula to, use a geometric sequence to find a certain term number, and then use all these skills to answer word problems. All right, so that's what we're going to be looking at this week. So here are some examples. If the sequence is a geometric sequence, then write both explicit and recursive formulas for it. All right. So to determine, is it a geometric sequence? It's being multiplied by the same thing. It's being multiplied by 3 each time. 5 times 3 is 15. Times 3 is 45. Times 3 is 135. So it is a geometric sequence. So if I want to put it in the explicit formula, I would just take, I'd say AN. Remember, when they say formula, we always just use N. All right. First term is 5 times the common ratio we said was 3 to the n minus 1. That's all you're doing is you're taking those two numbers, the first term and the common ratio, and putting it into the formula. The n, since it's a formula, the n stays as an n. The recursive formula, right? Same thing. An equals, this time it's a to the n minus 1 or subscript 1 times the common ratio, which is, we said was 3. And then down here, all you do is just say A1 equals 5. So for whether you're doing recursive formula or you're doing explicit formula, it doesn't matter. You're just putting those two numbers in where they're supposed to be. All right, and I'll make sure when you're doing the assignment today that you'll have the formulas at the top of the page. The next example says, given the explicit formula, write the first 5 terms of the geometric sequence. Well, so we're working backwards now. Now we have the formula, so we get those numbers out of the formula and do the sequence. So the first term is 4 because that's in the spot. So 4 is the first number. The common ratio is 3, so we're just going to multiply 4 times 3 and get 12. 12 times 3 is 36. 36 times 3 is 108. And 108 times 3 is 324. And so we just worked our way backwards. Instead of going from the sequence to the formula, we went from the formula to the sequence. And that's pretty much all we're going to be doing. Let's go to the next one. Here we go. Given the sequence, find the 14th term. So here we're going to take this sequence. It tells us it's a geometric sequence. We're going to take it and we're going to put it in the formula to find the 14th term. So we need to find the 14th term. All right, in the formula, A1 comes first, so 2. Remember, this is the explicit formula. We never use the recursive. 2 times the common difference. Now be careful, this one is going up by a negative number because it's changing from negative to positive every time. So this would be times -3. So be careful when you put it in your calculator, make sure you put it in parentheses. All right, now remember the formula is to the n minus 1. So this is going to be to the 14 minus 1. N is the term number we're finding. So we plug that in our calculator, 2 times -3 to the 13th power, and we would get -3,188,646. All right. And all I did is I plugged that in my calculator and hit enter, and I got the number. And it makes sense because the number is going up by being multiplied by -3 every time. So by the 14th term, remember that's exponential. It's going to get larger and larger and larger until you can't even fit on the calculator. The next example says, given the recursive formula, find the 12th term. Remember, we can't use the recursive formula to find the 12th term. We have to use the explicit, but this gives us what we need to be able to use the explicit. Here's the common ratio, and here's the first term. So we're going to do the same thing. We're going to say A12 for the 12th term is A1 is 8 times common ratio is 2 to the 12 minus 1 power. All right, again, I'm just using the explicit formula. I plug it into my calculator, 8 times 2 to the 11th power, and the 12th term in this sequence would be 16,384. Okay, so again, all we're doing is we're using the formula to find a certain term number in the sequence. If we started off at 8 and we multiplied by 2 and we kept multiplying by 2, the 12th term would be 16,384. Right. So then the last thing we'll do is we'll do a word problem, which is doing the exact same thing we've done 3 times in a row, but it's just taking the information from the word problem. So Hector was stuck at home for several weeks. I don't know why he would be stuck at home for several weeks. And when he finished his math assignment, he would color in squares on a piece of grid paper. He started off with 1 square on the first day and doubled the amount for each day after that. How many squares will he fill in on the 25th day? So this is a sequence. Went from 1 square times 2 is 2, times 2 is 4, times 2 is 8, and just kept on going. So for the 25th day, how many squares on the grid paper would he color in? Well, so we'd put in our formula. I want the 25th day, so that would be the 25th term. All right, day 1, he colored in 1 square times what the common ratio is, he doubled it. So it's being multiplied by 2. All right, and then the 25 minus 1. So when you plug this in your calculator, you're going to get a huge number. So Hector was busy for a long time after that, because on day 25, he colored in 16,777,216 squares on his grid paper. A lot of grid paper. But that's the gist of the word problems. All right. So if you need help, I'm here on Remind or on Google Meets, and good luck.